Righto, so today we're going to look at the zero index and the power law. So when I talk about these two things, what I'm actually saying is the zero index is a really, really nice one. The power law, it's power, right? So we've got, biscuits. Let's make this a bit thicker. We like them big, we like them chunky. Right, so what we're doing here is we're doing a calculation, okay? We're saying some number with a base of a to the power of m, and then we're making it a power n. So what we're actually doing when we're doing this, the shortcut method is we're saying that m times a to the power of m times a to the power of m, and we're going to do that n times. Now that looks really, really complicated, and I actually really dislike the way that math textbooks always do that. Sorry, Mr. Stuart Palmer. But what I'm going to say to you is, if I pick a reasonable example, like say 3 to the power of 2 to the power of 4, right? So that just means all I have is 3 squared, and I've got 4 of them. 3 squared, 3 squared, and 3 squared, right? So I got 4 of them. So I got 2 plus 2 plus 2 plus 2, which is going to be 3 to the power of 8. Now, somebody really, really sensible once said, what we could do is we could go, you know what? That's just 2 times 4. Well, and you know what? They're right. It's going to be x, say it's x to the power of 6 to the power of, let's pick a hard one. Let's go 5. Right. So what we're going to do is we're going to say that that is x to the power of 6 times 5. Now, 6 times 5 is one of my favourite numbers. It's 30. It's also not my age. It was my age at one stage, but it's not my age anymore. So what we're going to do is we're going to say that that is our power law. Power law is really, really nice. It just means that we multiply, okay? And multiplying's fun. Multiplying, it doesn't matter. Now, usually when I talk about multiplying stuff, there's always that tricky question, that one that has an idiotic thing in there, that little bit extra that math teachers put in there to really annoy you. So here is a hard one. So with a hard one, what we're looking at here is, say, for example, we've got 3 lots of, I'm picking on f today. Right, so we got f to the power of 5, and then we're going to take that power of 5, and then we're going to increase it up to the power of 4. I did 6 again. I can't do 6 again. I'll have to make it 7. So we've got 3 lots of f to the power of 5 times 7. So that 3 lots of is outside of the power. It's not actually raised to the power, so that means that we're going to have 3f to the power of 35. That's a hard one, okay? As you can see, they don't always have really, really hard ones. Sometimes they got nice ones. Now, the zero index is still my favourite index. I love zero index because it says that a to the power of 0 equals 1. Now, anything to the power of 0 equals 1. So that means that if I go 3 to the power of 0, that's going to equal 1. If I go 8 to the power of 0, that's going to equal 1. If I go 100,000 to the power of 0, that also still equals 1. If I have a letter, say for example, let's go G. I haven't done a G for a while. G to the power of 0 equals 1. Now, there is always a tricky one. We always got to keep our eye out for the tricky one. And with the tricky one in the zero index, it's when we do an addition or a subtraction or a multiplication. So if I said 5a to the power of 0 plus 3b to the power of 0, I would end up looking like a bit of a twit if I didn't do the multiplication separately. A to the power of 0 is 1 plus 3 lots of b to the power of 0, which is also 1. So I'm actually get out with a number, an answer of 8. Now, 8's a really nice number. I like 8. Now, we're up to the weird one. Now, I always hate the weird ones. 3 over b to the power of 6. Now, fraction rules. What you do with the fraction is you literally do the exact same thing. So it's going to be 3 to the power of 6 over b to the power of 6. Now, if we were asked to, we could evaluate that and we could say that 3 to the power of 6 turns out to be 3 times 3 times 3 times 3 times 3 times 3. And my friend here, Rafay, reliably informs me. Oh no, he's gone all shy now. He's not going to tell me what the answer is, but we'll ask him a little bit later. We'll hit him up. Oh, thanks, Rafay. He just held it up to me. 729. I was a bit disappointed he didn't manage to do that in his head. I expect better from him. Right, so the other weird one that we can get is, and that's just one type, the other weird one we can get is if we have a fraction like, say, 3 over 5, but we have it to a negative index, and that just means that all we need to do to get an answer to that one is flip it. Now you can combine each one of these things when we go through, but that's going to get you through the 0 index, and that's going to get you through the power law. I'll leave you to it. Have a great day.